So the next thing I'd like to discuss is the absolute value equations and inequalities. Um, so we've discussed equations and we've discussed inequalities, but we haven't really discussed when you include an absolute value sign. So an absolute value quantity is non-negative. And because the opposites of a number have the same absolute value, so say the absolute value of 5 and the absolute value of -5 are both the quantity 5, an absolute value equation can have two solutions. So with that in mind, I'd like to go over a basic absolute value equation. And what we're going to look at is we have here 2x minus 1 absolute value of 2x minus 1 equals 5. Alright, so this, without the absolute value sign, this would be a fairly basic equation that you would just solve for x, using every tool that you have in your tool belt. But with the absolute value sign, it changes things a little bit. So what you're saying is that this quantity, the absolute value of this quantity, the non-negative version of this quantity, is equal to 5. So when you're taking 2x minus 1, you're taking the absolute value of 2x minus 1. What you're saying is that 2x minus 1, well, 2x minus 1 could be 5. That's true, right? 2x minus 5 equals 5. 2x minus 1 equals 5. But it could also be, 2x minus 1 could also be -5. -5. So if you were taking the absolute value of this quantity, and this quantity was equal to -5, you would still get a solution of 5. You would still result in 5. So both of these are accurate. So we need to solve them separately. In this case, I'm going to add 1 to both sides. And I'm going to get 2x equals 6, or x equals 3. And in this case, I'm going to add 1 to both sides. And I'm going to get 2x equals -4, and x equals -2. Alright, so now we have two different values for x for just one absolute value equation. So that's what I was talking about in the beginning. Well, what we need to do now is we actually need to check to make sure that both of these values are possible. So I'm sure you've seen this many times before. Check your work. So let's check our work. If we were to plug in x equals 3 into this equation, we would get absolute value of 2 times 3 minus 1 equals 5. Well, that's 6 minus 1. 6 minus 1 is 5. The absolute value of 5 is equal to 5. So that checks out. That works. And then for x equals -2, we can plug in here. Let me grab a different color. We can plug in here 2 times -2 minus 1 absolute value equals 5. Well, 2 times -2 is -4, minus 1 is -5, so the absolute value of -5 is equal to 5. Well, that is also true, so that checks out as well. So both of these answers are correct. These are both solutions to our problem. All right. So we can continue this even further, and sometimes sometimes you get something called extraneous solutions. Extraneous, maybe you've heard of this word before, extraneous solutions. Um, but I just want to look at an example here that will display that. If we looked at this absolute value equation of 3x plus 2 is equal to 4x, x plus 5. Well, let's break this apart. The same way that we broke apart the previous problem, well, the absolute value of 3x plus 2 is equal to 4x plus 5. Well, that means that 3x plus 2 could equal 4x plus 5. Could be. Or it could also, 3x plus 2 could also equal negative quantity 4x plus 5. So that's very important that you put the negative sign in and then the quantity of 4x plus 5. 4x plus 5 in parentheses, because if you don't do that, then you're just going to have a negative 4x and a positive 5, and that won't work out in the end. So we're going to go ahead and solve each equation. I will bring 3x to the right side and bring the 5 to the left side. I'm just doing 2 steps in once here. So this cancels with this cancels with negative 5 cancels with the positive 5. And then we have 2 minus 5, which becomes negative 3, is equal to x. So we have x equals negative 3, or we have 3x plus 2, and then I'm going to distribute this negative sign. So this is really just like writing negative 1 here. And then that negative 1 is being distributed to both terms inside the parentheses. So now you're getting negative 4x minus 5. Okay, so I'm going to solve this equation. Bring the 4x to both sides. Bring the 4x to the left side. And then we're going to bring the 2 to the right side by subtracting 2 from both sides. These 4x, positive 4x and negative 4x cancel, negative 2 and positive 2 cancel, and we're left with 7x equals negative 5 minus 2 is negative 7. So we get x equals negative 1. Alright, so now we have two values. We can still bring down this or. So now we have actually two values of x, just like we did in the previous problem. So let's check our work. Let's see how we did here. If I plugged in negative 3 into the problem, I would get 3 times negative 3, or absolute value of 3 times negative 3, plus 2, close absolute value, equals 4 times negative 3, plus 5. Alright, so 3 times negative 3 is 9, negative 9, plus 2 is negative 7, so I have the absolute value of negative 7 is equal to 4 times negative 3 is negative 12, plus 5. Okay, well, what I'm seeing here now, this is actually equal to negative 7, and the absolute value of negative 7 is 7, and 7 does not equal negative 7, so that cannot actually be a solution. That's not possible. Let's check our x equals negative 1. So if I were to plug in this, I would get 3 times negative 1 plus 2, and this is all in absolute value, equals 4 times negative 1 plus 5. Alright, so 3 times negative 1 is negative 3, plus 2 is negative 1, so we have the absolute value of negative 1 equals 4 times negative 1 is negative 4, plus 5, well, absolute value of negative 1 is just 1, and negative 4 plus 5 is 1. So this one actually checks out. So our only solution to the equation is actually x equals negative 1. X equals negative 3 does not satisfy the original equation, so x equals negative 3 is actually an extraneous solution. So this is an, let's see if I can fit it in here, extraneous solution. Okay. And that's all.